Hello friends. So in the continuation of CTQ 11, in the part 4, we will see that if there is any disturbance in the supply of the second stage of the structure that we had drawn the second circuit, then what is the output due to this perturbation or due to the supply change. So if I'm using the only this structure which is called the common drain, or we call the only source follower structure, then what the effect of this supply perturbation or the disturbance in supply, and if it is nothing but gain boosted structure that we have seen. The gain boosted means amplifier is used here. Gain boosted structure. Okay, this is the only common source source follower structure. We have to see which one is better in terms of supply noise rejection or supply perturbation rejection. Okay, so if I analyze the first circuit, when we are seeing the perturbation in supply, then of course we will ignore this means any change in the input, or we will short the input. And here by means perturbation supply simply means we are applying some sort of signals on the this node. Okay, that is nothing but a small voltage signal that I will also consider as the input signal voltage. There is nothing but a signal or small signal voltage that we are applying. Okay, so we have to do the simple analysis that what we do for any gain block. Overall, I mean to say we have to calculate the gain from V into V out, where V is nothing but this del V is a supply perturbation, supply disturbance or perturbation, supply disturbance. Okay, if I want to calculate this gain, then one the strong asset that I know I'll use to calculate the gain is this. I always consider my ID expression, which is nothing but a current from drain to source. And I like to write this ID expression, which is nothing but GM plus GMB plus GDS. Okay. So yes, we can consider the body effect also because the body is zero. So what we can see IDS, what is GM, and get it as your ground. So we can consider like a minus V out. Okay, body is also at ground, so I can consider GMB minus V out. Source is at V out. And what we speak of GDS. GDS VD, drain is connected at your del V, which I call the input voltage. As of now, the supply disturbance minus V out. Okay, this is your ID. So what exactly we are getting for the ID? We can translate it to the output voltage, like it can be written minus V out GM plus GMB. I'm considering all the effects, but you can ignore it at the time being. But here GDS effect has to be considered because my del V, which is nothing but a supply perturbation, associated with the GDS term only. Okay, so this is the ID. And what is the output? The output is nothing but ID times R. So we can put this ID here. Let it is called the second equation, it called the first equation. I can put my, and one more thing for a timing I can ignore here. Here I can consider ignore these things because GM is much greater than the GDS and GM is greater than your GMB. Just I'm taking the assumption they are also right to some good extent. Okay, so I can write as head equal to minus GMB out plus del V GDS. I think, yeah, del V GDS. So what is my V out? My V out comes to be ID times R. It can be 10 minus GMR V out plus GDSR del V 1 plus GMR equal to GDSR del V. Okay, so what is the gain we are observing? from this output to supply perturbation is GDSR by 1 plus GMR. Okay. So as you know that it is expected GDS is much smaller than this GM. Okay. If I'm considering that my GMR is much greater than 1, then what can be this gain expression from supply perturbation to the output can be GDS by GM. And we know that GM is much greater than, so it is nearly to 0. And this is the expected result. Expected result. Because what we want, if there is any change happening in the supply, it should not go or it should not translate to the output. Okay, this is a better supply rejection, supply noise rejection. So what we can conclude here, this circuit is rejecting the supply perturbation nicely. This circuit is cancelling the supply disturbance, supply disturbance in a great extent or good extent, I can say. Is what we are seeing. We are seeing that this particular gain, I should say del V out. I can also write the del V out or V out. This V out is also a small signal voltage, but I'm writing del V out to look it good. It is called supply rejection. This is nothing but nearly comes as GDS by GM. It nearly comes as 0 because your GM is much greater than GDS. It should be there. Now, what is this particular calculation for the second circuit? Okay. So let for this block, the supply is a regulated one. So I am not worried about its supply, and I consider it to be ground. And what I want to see, I want to apply del V here, and I want to observe del V out. Okay. So what is happening here? Let we call it X. So what is the Vx? Vx is minus A times del V out. And what is this ID? ID can be written as, and yeah, one more thing I will do that. V out is nothing but IDR. Okay. Yeah. So what is the ID? ID is GM VGS. What is VG? G is your X, and this is your del V out. Let go del V out. Okay. GM VGS plus GDS del V minus del V out plus GMB minus del V out. Okay. So what means minus del V out? What we can write? GM plus GMB plus GDS, where I will again ignore these things. Just I am writing to make you clear again the thing. Plus del B GDS. I am just writing these GMB and GDS again and again so that you can be habitual of writing these things in your current equation so that you can directly find again when there is a body effect consideration. Okay. Yes. So this is the thing that is the ID. Now, what the V out? What I call del V out is called del V out. So del V out equal to ID, which is I times R. So minus del V out R. It is nearly I'll consider GM because other terms to be small GDS. Okay. Here the assumption is that again GM is much greater than your GDS. Here the inherent assumption in GMB. This thing is not that accurate, but this thing is 100% accurate. But here the relation we consider let 4 to 5 times of GMB. Okay, this is a usual. But even I'm considering it's a much greater. So what we can write here? Okay, what I can write here? Vx, where is the Vx one? Okay, the one thing that is missing in the ID is GM Vx also. Okay, so that I write plus GM Vx also. Okay, so what we can write? We can write del V out equal to minus GMR del V out, okay, plus what do you call del V GDS minus A times GM del V out. Anything missing? Vx GM Vx I. So IR. Okay, GM Vx times R. So what I write here? R as well. Okay, so I think it is good, or something is missing. Del V out equal to R also here. Okay, GDS R. Yeah. So what it can be? Del V out. Let's take del V out common. 1 plus GMR plus AGMR equal to del B GDSR. Okay. So what is your del B out by del B? Is nothing but GDSR divided by 1 plus GMR times AGM. So what we can see, okay, what in the previous circuit we have seen that rejection ratio del B out by del B SS was what? GDSR divided by 1 plus GMR. This was for the circuit 1. And what is for the circuit 2? Where we are using some gain boosted structure. GDSR is still there, but in denominator, what is there? 1 plus GMR plus A times GMR. Okay. So this is the extra term apart from this. So overall, when what we will see if we compare these two, this is the circuit 2. Circuit 2. So circuit 2 is giving the better supply uh, rejection ratio. Supply rejection ratio simply means if there is any disturbance in the supply, the circuit second is rejecting it better, because this is if let I am just figuring out with some numbers. Let I am saying this GDSR is nothing but 5, and let's say GMR is nothing but 10, and let take A is your, let's say, 10. And what it is for the first circuit? For the circuit 1, what is the number? The number comes to be, or the number del V out del VSS comes. It is nothing but 5 divided by 1 plus 10. It is nearly 5 by 11. So nearly it comes as 0.5. Okay. And what is speak of the second circuit? For the circuit 2, for this circuit 2, what it comes to be? 5 divided by 1 plus 5 plus, sorry, 1 plus 10, because GMR is your 10. Okay. 1 plus 10 plus 100. So what? 1 plus, it is right now 11. How, not 11. So what it comes to be? It comes to be nearly 0.04. Okay. So it is nearly 10 times less. So the circuit 2 is rejecting this power supply perturbation in the better way. Okay. So this was the point here to tell you about how to analyze this thing. So just go through the fundamental equations, write down the gain from output to any input perturbation, and whatever the node we have. If we want to find effect on the output, then we can directly see it. Okay. And if we are seeing the effect on the output, and then we can see which circuit is better for which particular disturbance. Okay. So here what we are seeing that there is a output disturbance given in two circuits, and in these two circuits, the circuit one is simple source follower structure, and where this output means this supply disturbance is influencing the output, and we have calculated this gain, and for the second circuit we also calculate the same gain. But for this structure I am considering that the supply of my amplifier is well and good, so I'm not worried about the supply of my amplifier, which is the GM channel. Okay, for the time being. And we have seen the calculation of both the gains from supply to output, and we have seen the circuit 2 is rejecting the supply perturbation in better way. Or here with the quantification in the example we have seen, with this quantification data, the circuit 1 has given me nearly 0.5, while the circuit 2 is giving me the value of this particular gain to be 0.04, nearly 0.05. Okay, so it is a nearly 10 times lesser, so it's better for us. So one thing left for this circuit, because I was also considering one parallel circuit, means one circuit in parallel of this circuit also. So if you want to see this power supply rejection for this circuit, then what will happen? So one circuit was this all as well. Sorry, it is BDD, not BSS. By mistake, I have written the BSS on top. So this was one more structure that we were considering parallelly. Okay, so I should write here BDD, and here if I'm having perturbation del V, okay, then what will be the effect? We'll see it, the effect on the output. Okay, so let now consider this thing first. So what we will see, I am applying a del V signal here, and input is to be shorted, or this is my del V out. Okay, I can order del V, or I can write it del VSS or supply, or I can write it as the supply del V dd, or I can write it as a simple V network. Anything I can write. Okay. So simply one thing that I know, the strong asset that we have, always consider your current ID. And what we have to write? You have to write the expression of the ID. ID is what? ID is GMVGS. Always consider direction from drain to source. GMVGS plus GMVBBS plus GDS BDS. Okay, here no body effect, because even if it is connected to supply, yes, one thing here to be observed is that, yeah, as we connect it with the supply, so it is connected to the del B supply, so there is, I can consider the VBS is to be 0. Okay, so it is connected to the supply, not a problem. So ID here is what? GM. What is the VG? VG, get is a ground. What about source? Source is at the minus del B. Or simply I can say it is a means supply disturbance. Okay. What do you speak of GMB? GMB is term is not existing here. And what do you speak of GDS? GDS. What is VD? Drain is at your del B out, and source is at your del B. Okay. This is your current ID. And what to speak of del out? Del V out. Del V out is nothing but minus ID times R. So what it can be? It can be GMR times del B. It can be minus GDS R times del V out minus del V. Okay. So if we separate both the variables, del V out on the one side, and it will be 1 plus GDS-R equal to 1 plus GMR. Okay, so I think anything is missing here, or okay, okay, with this del V, not 1 plus, rather there is one more term, that is a, so here we have GDSR. Here we have GDSR. So what we can write? We can write for the first circuit del V out by del B supply as GDS plus GM R divided by 1 plus. I think if I'm not wrong, the expression is correct, and you can see what is the result coming here. Okay, GM is much greater than GDS, always we consider it. So this term is coming very high. You can see this term coming very high. If the calculations are correct, then it is right to say that term is very high. And okay, that consider that GM is much greater than GDS, and what we can see, this result nearly comes out to be GM R divided by 1 plus GDS R. Okay, let's leave it here. Now consider the second circuit. This to be shorted. Here I am applying del V signal. Del V out we are observing here. Okay, so for this to consider, we will again use a set, strong asset. Let's say this is X. This strong asset is your ID, and ID is GM VGS plus GMB BVS plus GDS VDS. Okay, this thing is to be 0 because no body effect is here. So GM, what is gate voltage? Gate voltage is Vx. What is your source voltage? Minus del V. Okay, what GDS? What is your drain voltage? Is del V out. What is your source voltage? It's del V. Okay. Oh, this is my I. And what is the Vx? And Vx is here. Vx is nothing but minus A times V out. That we can put instead of V. What is the ID then? ID is nothing but GM minus A del V out minus del V plus GDS del V out minus del V. And what is the del V out? Del V out is minus ID times R. So what we can write here, minus GMR minus A del V out minus del V. Sorry, one thing I'm missing here. It should be plus. It should be plus. It should be plus GDS R del V out. It is minus, no? Okay, so minus GDR. Okay, so let's take the del V out term on the one side. 1 plus GDSR, okay, plus AGMR. Del V out is separated. Now comes to GMR, sorry, AGMR, GDSR, okay, plus GDSR, this to be del V. So what is del V out by del V? It is coming as AGM plus GDS times R divided by 1 plus GDS plus AGM. So this is the expression I am getting here. Okay. So what we can see, what we can see from here, the assumption that it is a very strong assumption here now. So the net term comes to be AGM R divided by 1 plus AGM R. So what it comes to be? It comes to be nearly 1. Okay, so it is better than the previous circuit. What the previously we have seen? We have seen del V out by del V for the first circuit was what? GMR divided by 1 plus GDSR. Okay, so as I'm considering that GDSR is smaller than 1, and what we can say it is nearly coming as GMR. While what is coming for the second circuit? Second circuit it is coming for nearly 1, which is nothing but AGMR divided by 1 plus AGMR. Okay, so the second circuit is rejecting the supply noise in the better way. Okay, so this is for circuit 2 and this is for circuit 1 in the second case. Okay, so this circuit is rejecting in the better way. We can see it comes nearly 1. In comparison of previous circuits, whatever we have seen for the source means source follower structure, there the noise supply noise rejection was better, but here it is a little bit disturbed, or it is far off, but even it is better for the gain boosted structure. It is nearly 1. Okay, so without gain boosted structure for common source, or we can the source follower, yes, common source structure, it is very poor. We are getting a lot of gain from means supply disturbance to the output. So if we are getting gain from supply disturbance to the output, then what is the problem? Problem is that if there is even a means very small disturbance in the supply, which is very usual, that's why we use the regulated supply. If there is even a means little disturbance in the supply, we are getting the gain at the output. It means it is not a good design, or it is not a good environment where my design is existing. Okay, so we must have good supply rejection, where the meaning is that if there is some disturbance in the supply voltage, which is a fluctuation very common, we can go plus minus 1%, plus minus 5% even, or plus minus 10% also to the supply. In that case, our circuit should be robust to this particular disturbance, so that the output we are getting due to this disturbance is very less. So which we have seen thoroughly in the discussion, and also in the previous discussion for this particular circuit, where we had the common means source forward structure. Okay, so I think this is clear for this video. Thank you.